Okay, good afternoon, class. I hope everybody is staying safe and feeling okay during this crisis that we're experiencing all together. We are going to be starting distance learning starting Monday, April the 6th. Make sure you're tuning in every day and checking your Google Classroom. So I'm just going to start off by saying that this flame test lab, which you did before the March break, I changed the due date to Tuesday, April the 7th. So if you were not here during this flame test lab, I'm going to ask somebody from the class to post up the data they got. So I'm just going to review the lab. Basically what we did is we took a metal solution. So for example, copper, so we took, for example, copper chloride, this powder, and we mixed it in water in a spot plate. And then we put a wire, dipped it into that solution, and then put it into the flame after lighting the Bunsen burner up. And we saw a unique color. So for example, you would see copper burning green, and that's unique to that element. So you tested, I believe, 6 or 7 metals, and then you had like what color they burned in the flame, and you made an observation chart, and I'm just requiring you to answer these analysis questions. That's it. Okay, so if someone could please put up their data chart from the observations on Google Classroom, that would be very much appreciated. Okay, so let's get started with today's lesson. Today's lesson is on ionic compounds, which I have posted on your Google Classroom. So let's get started here. Okay, so today we're going to learn about how ionic compounds are formed. You're going to be able to tell me what is the octet rule, and you're going to be successful when you can explain the difference between atoms and ions, name positive and negatively charged ions, define cation and anion, explain how ions are formed, describe the octet rule, and understand some properties of ionic compounds. Okay, so some introductory items. So just remember as you're watching this lesson to take some notes on a piece of paper or notebook. And if you have any questions as I am explaining concepts, you can bring them up during our Zoom meeting, which is on Monday, April 6th at 2:30. So just an introduction, atoms are electrically neutral particles and ions are charged. So they can either be positive or negative. And how do they become positive or negative? They gain or lose electrons. So if an atom is gaining an electron, remember electrons are negative. So if you're gaining something negative, you're becoming more negative. If you're losing an electron, you're becoming positive. Okay, so again, when an atom gains an electron, which is negative, it becomes negatively charged. When an atom loses an electron, it becomes positive. Why do ions form? So atoms gain or lose electrons to form a stable octet, which means they want to have their outermost shell full. What does it mean to be full? To have 8 electrons or a full octet. This refers to the outer electron shell being filled to its capacity. Every atom wants a full outer shell so that they can be stable. The electrons in the outer shell are called valence electrons. Okay, so there's 3 ways to achieve a full octet. You can lose electrons or gain electrons, and the last way is to share electrons, and we'll be talking about that in the next lesson. It's how covalent compounds are formed. The octet rule. When atoms combine, they tend to achieve 8 valence electrons. A full or stable octet is an electron arrangement where the valence shell is filled with 8 valence electrons, or in the case for helium, a full outer shell would be 2 because it only has the first shell and it just needs 2 to be happy, or full, I mean. Okay, so example number 1, let's look at magnesium. Magnesium has 12 protons, 12 electrons, and 12 neutrons. and the mass number is 24 from your periodic table. So if we had to draw the Bohr-Rutherford diagram of magnesium, it would look like this. 2 on the first shell, 8 on the second shell, and 2 on the last shell. So if we had to draw the Bohr ion, these 2 electrons on the outer shell would leave, okay, and you would be left with the shell that's right below it, which has 8. Okay, so that's shown here. And because the 2 electrons left, the charge is +2. Okay, if we had to draw the Lewis atom of magnesium, whoops. So magnesium, the element, this is supposed to be moved over here, but it has 2 electrons. And then if you had to do the Lewis ion, it would have 8 electrons on its outer shell. Okay, let's do oxygen. So oxygen has 8 protons, 8 electrons, and 8 neutrons, and the mass number is 16. So if we had to draw the Bohr-Rutherford diagram, it would have 2 electrons on the first shell and 6 electrons on the second shell. So the outermost shell has 6. So how is it going to achieve 8 or a full octet? Should it lose 6 or gain 2? So gaining 2 is a lot easier than losing 6. Okay, so when it gains these 2 electrons, it becomes stable or happy and full, and the charge becomes -2 because it's gained 2 electrons, shown here in the red. Okay? And then this is just showing you the Lewis diagram, showing you just the outermost electrons. Okay, so here it's showing you that these 2 red electrons have been added for a full charge of -2. Okay, positive ions. What are they? So when you say cation, think positive. I don't know if you guys like cats, but I always think of a cat as something positive because it's fluffy, it's warm, and sometimes they're cute. So a cation is something that's positive. A positively charged ion formed by the removal of 1 or more electrons from the valence shell of a neutral atom. When a cation is formed and at least 1 electron is removed, you need energy. Energy has to be put in for that to happen. So that's a requirement to form the cation. Anion formation is when you're forming a negative ion. So when you're adding an electron to a neutral atom, and when you form an anion, energy is actually released or produced, as shown right here. So when you add an electron, energy is released. Okay, so hopefully you know on your periodic table that family 1 always forms +1 ions. Family 2 always forms +2, and then we jump the transition atoms to family 3, which forms +3. Family 4 is +4 or -4. Family 5 is -3 because it's going to gain 3 electrons. Family 6 is -2, and family 7 is -1. And then family 8 does not react because it's already stable. Okay, so now we're going to go over names and symbols for ions. So remember, positively charged ion is a cation. So example, these are pretty straightforward. When you see a sodium ion, Na+, you just say sodium. Negatively charged ions, you have to change the ending to "ide", I-D-E. So for example, if we had fluorine, that is an anion, F-1, so you would say fluoride ion. Okay, let's name the following ions. Calcium, Ca2+, Al3+, Br-1, N-3. So how you would name them is just basically what the element is. So calcium, aluminum, and then these are negative, so you have to change the ending to "ide", so bromide and nitride. Okay, so let's talk about multiple ionic charges. So if something is multivalent, it's usually in the middle of the periodic table. It can have more than one charge. Some elements can form cations with different charges in compounds. Okay, you do not have to copy this table. That's not necessary. Some examples of multivalent ions is copper, Cu. It can be +1 or +2, but they will always let you know what it is. Okay, what is a polyatomic compound? So polyatomic compounds are found in many places. Potassium nitrate is in fertilizers. Sodium bicarbonate, which is baking soda, is used in baking and cleaning. So what is it? It's an ion that consists of a stable group of several atoms acting together as a single particle with an overall charge. So here are some examples of polyatomic ions. Notice the trend for polyatomic ions is the ending is usually ate, A-T-E, except for hydroxide, that's an exception. But you can always recognize a polyatomic ion with the ending A-T-E. You will always be given polyatomic ions on the back of your periodic table. So you don't have to memorize them. Okay, so for example, nitrate is NO3, -1, hydroxide is OH, -1, chlorate is ClO3, -1, and so on. Okay? All right, so we're gonna practice now. Let's name the following. So what is CaNO3 2? So Ca is calcium, and NO3, this is a polyatomic ion, so you should recognize that it's a nitrate. So the answer is calcium nitrate. Okay, next one, LiClO3 is lithium, and then ClO3 is chlorate. K3PO4 is potassium phosphate. Okay. So let's try this one together. Maybe try it on your own on the side if you have a piece of paper. Try to write the name of this compound. So Cu, what is that? And then what is NO3? So I'll give you a second there to look that up on your periodic table, or you can pause the video. Okay, so the answer is copper nitrate. Okay, so I wrote out these steps for you, but you really don't have to do that. You write the name of the metal first. So since copper has two possible charges, +1 or +2, how do we figure out what charge it is? You just do reverse crisscross. So NO3 has a charge of -1, so the 1 went down here. And then if you look here, there's a 2 there. So that means the copper had a +2 charge if we did reverse crisscross. Okay, so that's how I knew that it was copper 2 nitrates. And the 2 you write as a Roman numeral. Okay, and again, if you have any questions about this, please write them down and you can ask me at our Zoom meeting. Okay, let's write the chemical formula for the following. What is ammonium nitrate? So ammonium is NH4 +1. Nitrate is NO3 -1. And then you have to crisscross. So I will be doing this on a piece of paper for you. So just 1 second.